Welcome to another demonstration of What's New in NXCAM. This video will show you how you can now specify either a U or V control direction and ignore system-defined vectors, allowing you to interpolate the tool axis for variable axis operations along the U or V ISO curves with as little as a single interpolation vector for each curve. This capability greatly simplifies the task of specifying a constant tool axis orientation along the entire U or V curve. Double-click along wall to edit the operation. Click Verify. Click Play. Notice that the tool holder collides with the part on the last pass. We'll edit the tool axis by tilting it so that the holder avoids collision and the tool maintains a constant orientation while moving in the U direction. Click OK to complete the visualization. In the Tool Axis section of the dialog box, click Edit. Select Linear from the Interpolation method list. Control direction is new. The U and V option retains the behavior from previous releases. The U option controls the tool axis in the U direction only. The V option controls the tool axis in the V direction only. These two options give the new behavior. Select U from the control direction list. Notice the two ISO curves. Each ISO curve contains a system-defined vector at each end. Only one vector is now necessary to define the tool axis along each ISO curve. Select Vector 4 in the list. Select the Ignore Point checkbox. This option is new. It allows you to ignore system-defined vectors so that they are not considered when interpolating the tool axis. Select Vector 2 from the list and select the Ignore Point box. Select Vector 3 from the list. In the Graphics window, rotate Vector 3 so the tool no longer collides with the part. In previous releases, the tool was rotated about the tool tip, resulting in the tool cutting below the part surface. The tool now rotates about the contact point and no longer violates the part. Click OK to save the vector definitions. Click Generate. Click Verify. Click Play. The tool holder no longer collides with the part wall, but the tool axis begins tilting sooner than necessary. This is because NX tilts the tool continuously as it interpolates the tool axis between the two U curves. Click OK to complete the visualization. Adding an ISO curve allows you to control how long the tool remains vertical before tilting. In the Tool Axis section of the dialog box, click Edit. Click Add New Set. Select a point on the edge of the part at the approximate location indicated. This defines an additional ISO curve with a vector that can be used to control the tilt of the tool. By leaving the ZC vector vertical, the tool axis will remain vertical as long as it approaches the wall until it reaches this curve. Click OK to save the vector settings. Click Generate. Click Verify. Click Play. The tool axis remains vertical until it reaches the added ISO curve. It then begins to tilt as it approaches the next ISO curve. Click OK to complete the toolpath visualization. This concludes the demonstration of how you can now specify either a U or V control direction and ignore system-defined vectors, allowing you to interpolate the tool axis for variable axis operations along U or V ISO curves with as little as a single interpolation vector for each curve. Thank you.